Hello, everybody, friends and family of Alex. Thank you for coming. I'm Leigh Stearns. I am a professor in the geology department. Alex and I work together. Alex did all the work and we chatted once a week about the work he did, which was really a fun project for me. So you all know, but I will tell Rick, who's also professor in the department here and our honors coordinator. Alex is a senior here at KU from Lawrence and then from Colorado. And now lucky to have him back in Lawrence for the spell. And he's going to talk, he was kind of, I guess, initially excited about studying this region in more detail after spending the summer there last year from his kind of internship with Nature Bridge Coastal Camp, and wanted to learn a little bit more about the background and how this park might be impacted by climate change. That's what we have been working on together this term. And you ready to go? So the way this will go is he'll give a talk and then we'll have questions from the audience, anyone who has questions for him, and then Rick and I have questions.
That's the way normal.
Okay, and then yeah, so then we yeah, and then we'll kick you out, and Rick and I will chat with Alex a little bit, and then that will be that. So
if you were here today, you're here to learn a little about climate change in Golden Gate National Recreation Area. And so basically, like as Dr. Stearns introduced, taking a little closer look into Golden Gate based on what I experienced this summer and want to look more into. So we're looking into kind of like the back order events we're going to talking about, including introducing what Golden Gate exactly is. And then we're of course getting in with questions. So hope you enjoy. So introduce what exactly is Golden Gate National Recreation Area and where is it? So we're gonna take a little trip from here in Kansas, outside of Lawrence, away from Kansas, all the way out to the west coast of California and the San Francisco Bay Area, where Golden Gate National Recreation Area is located. It was established by the US Congress in 1972. And it's about the most visited park in the national park system. However, it rivals that with Blue Ridge Parkway, which goes back and forth. But they do see over 15 million visitors per year, which is about 2 million more visitors than Great Smoky Mountains and about 8 million more than Yellowstone. So it sees a lot of people per year. But along with that, Golden Gate is also a very large area. It's about 82,026.5 acres, which is almost 3 times the size of the actual San Francisco city area, making it the 3rd largest urban park in the world. So to actually understand the climate and the present conditions of Golden Gate, it's important to understand the history of Golden Gate and what led to being here now. So the first thing off would be the geologic history. Golden Gate is located along and actually on top of the San Andreas Fault, with the Pacific Plate moving north past the North American Plate at about 1 inch per year, which is actually slower than your fingernails grow. So it's a very slow moving fault, and it has been active in the Bay Area for the past 12 million years. But the San Andreas Fault combined with the Hayward Fault, which is on the east side of the bay, those 2 faults combined are responsible for this rugged terrain that is found around the bay and in Golden Gate. This can be seen through the topo relief of from sea level to the top of Mount Tam, which is around 2,300 feet. The area is a former subduction zone with the oceanic crust going beneath the North American continent. So there is a lot of former volcanic and rock that is found here, such as basalt. But all of this rock here is about 250 million years old and part of the Franciscan complex. But together, these 2 plates form the San Francisco Bay Area around 650,000 years ago. So the Bay Area itself is relatively young. However, even younger than that, due to sea level rise in the past, due to glacial periods, sand dunes actually formed and covered the San Francisco area about 5,000, 8,000 years ago when the sea level started to stabilize during the last glacial period, which peaked about 19,000 years ago. So understand the actual geology of the area. This is the actual geologic map units found in the area. So it's mainly the Pliocene and Holocene, which is more of the younger sand dune area formed by the glacial retreat. And then there's also the Mesozoic, which is mainly Cretaceous and Jurassic area, which is mainly found as the Franciscan complex. And you can see from this map here, on the west side, there is the San Andreas Fault here moving north of the park, and on the east side, the Hayward Fault. So it's in between these 2 faults, as you can see, and this is where Golden Gate is where we're focusing today. As you can see from on the pictures here, how complex even the beach rocks here found on Rodeo Beach and the rock wall beneath, above Fort Cronkite, but below their water tower. It is made of radiolarian chert during this Franciscan complex. And you can see with all the tectonic movement and folding of the rocks here that it is a very complex area that is made up from this past geologic history, especially here on Black Sands Beach, where there was a lot of faulting and folding that has occurred. And that can also be seen with the topo relief of the area at the hills and the ocean, and how all this combined helps trap in the fog, which will come in later with the importance of the climate of the area. So now moving into, after the land is formed, into the actual people who are there. So the original people who are here and are still here today are the Coast Miwok and the Ohlone. This is their original land and their ancestral land, as you can see what is overlaid today. But where we're going to be focusing today is mainly on Coast Miwok land and Ohlone land with the Muir Woods, Marin, Headlands, and the Presidio of San Francisco. But the indigenous peoples here, they arrived about 8,000 to 6,000 BCE, with mainly the Coast Miwok north of the Golden Gate and the Ohlone south of the Golden Gate. Today, they're mainly recognized as the Federated Indians of Great Rancheria, but that is mainly made up of the tribe of Coast Miwok and Southern Pomo. So moving forward past their presence there into the colonization period, it kind of started off with England coming with the arrival of Francis Drake in 1579, and then with the Spaniards coming in 1776 and establishing military garrisons such as the Presidio at the bay, around the bay entrance, which is known as the Golden Gate. This kind of kicked off the Spanish mission period, where they started to force Christianity on the indigenous peoples and bringing diseases over from Europe, which caused the population of the indigenous peoples to drop around 33% around this period. However, then the Mexican government came in eventually as they declared independence from Spain in 1821, and shortly after the United States invaded the land, claiming the land for the US. And a year later, in 1848, Mexico ceded the California land to the United States. And also in 1848 is when the gold rush began, leading to a high population boom to California in the San Francisco Bay Area. By 1870, though, about 80% of the indigenous lives in the area had been lost due to the diseases being brought by the Americans, by Europeans, and then also by a racially charged murder and wrongful imprisonment that they were put on in Alcatraz, and then even leading to a population of the Ohlone only being around 30,000 at that time. Then the US military came in and moved into the Headlands and the Presidio, mainly during World War I, World War II, and the Cold War, and they established numerous batteries and forts, including the Nike missile site, which was held a nuclear missile head in the Cold War. However, in 1972, the US Congress established Golden Gate for the National Park Service to preserve and interpret the land. However, the military didn't actually hand over this land area until 1994, and actually soldiers resided on the land until 2000. So now we're caught up to the present, is kind of the areas we're gonna be focusing on are the Muir Woods up north. Then we'll move south into the Marin Headlands, and then we'll move south across the Golden Gate Bridge into the Presidio of San Francisco. However, before I begin into my research, I kind of created an idea of what I expected to see. I expected to see a rise in temperature as global warming, climate change, that is normal. So I expected to see a rise in temperature, and due to being in California this summer, I experienced the fog, and I became aware of how bad the drought conditions were in California. So I kind of expected to see a drop in precipitation, and potentially with that drop in precipitation, rise in temperature and drought conditions, probably a change in fog as well. And working there this summer, I became aware of invasive species and non-native species living there. So with the knowledge of how they interact with climate change, I expected there to be a rise in invasive species due to these climate conditions, and also which would lead to threatening growth of the native species there. So moving forward into the actual research, we'll begin with the Muir Woods up north. Muir Woods established in 1908, and it was named after John Muir, who was a famed preservationist and is nicknamed the father of the National Park Service. The land was saved from logging and industrialization, primarily due to the geologic formation of the land. Muir Woods is located in the valley, which is very hard to get to and get wood out of. So because of this difficulty of the landscape, it made the trees here protected until 1908, when it became protected fully. The land is made up of about 558 acres, 240 of which are old growth coast redwood. And you can see by this map, this is the extent of the coast redwoods in Golden Gate as of today, as they have shrunk due to logging. However, what is unique about the coast redwoods is that they are the tallest of all living things in the world. The tallest in Muir Woods are actually around 258 feet, and just north of the park, they can get up to about 379 feet, which is 74 feet taller than the Statue of Liberty and its base in New York. But along with this being tall and the tallest in the world, it also lives a very long time. In Muir Woods, they're around 600 to 800 years old, with the oldest being around 1200, at least 1200 years old. And that is still very young because they can live up to be 2200 years old. However, they're not just really tall and really old, but they are also a great big carbon sink. Coast redwoods, they store around 2,600 metric tons of carbon per hectare, which is about 2.4 acres. And this is double the rate that is found in conifer trees in the Pacific Northwest, or even the eucalyptus forest in Australia. But what's unique about this also is that Muir Woods is home to more than 380 species of fauna and flora, not even counting all the fungi species that are found there. But what's home to these species is the coho salmon and steelhead trout. These are keystone species in the area and are also federally threatened and endangered species. And all of this forest and all of the ecosystems and all of the endangered species here, they are dependent on the Mediterranean climate that is created by the bay and the fog that comes in. But the Mediterranean climate is characterized by a warm, dry summer and a mild, wet winter. But again, like I mentioned, the fog in the bay, in the Central Valley of California in the summer, it heats up to be very hot, and that heat was what drags in and pulls in the fog off the ocean, and what cools down this forest and brings in a lot of moisture and also nutrients, because the fog carries a lot of unique nutrients, such as nitrogen, which acts as fertilizer for these trees and the forest. So the redwoods are able to absorb this nutrients through their roots, like a normal tree and plant. However, they're also able to absorb it through their needles, through stomata, and this is a process called foliar uptake. And like I said, this is a very unique mixture of the fog because out of a study from Humboldt State University, they were able to identify tree ring samples and able to see when the tree was actually getting nutrients from the rain versus the fog because of how unique the fog is compared to the rain with nutrients and fertilizing. And of course, when there is excess fog, the moisture will drop off the needles and go to the forest floor, feeding the rest of the forest and creating this large, beautiful ecosystem that is found there. However, of course, there is the climate that is affecting the area. Like I said, with the unique composition of the fog, the coast redwoods are dependent on this fog. Because I said with the warm, dry summers, without this fog, it is very dry, and the redwoods need this rain and moisture to feed themselves, but also the ecosystems there. And there has been a decrease in this fog by about 34.5%, which leads to about 3 to 4 hours per day, leading to a drop in humidity, drop in moisture content, fewer nutrients for the forest and the trees, and including less water in the forest. And along with that, there's also been a decrease in annual precipitation by about 10 inches per year since the mid-1900s. And along with that, there's been an increase in temperature, along with even the lowest of the anomalies going up as well. And along with, there's also been a drought and severity increase as dry conditions have gone up, with extreme drought conditions becoming more frequent. And with that, also potential evaporation going up recently. So with all these conditions combined, it is threatening the habitat and ecosystems of all these federally threatened and endangered species, such as the northern spotted owl, the coho salmon, steelhead trout, and what we'll talk about more later is the California red-legged frog. And with all these endangered species, there's also the non-native invasive species that are threatening the ecosystems and the species there. What's most noticeable is the forget-me-nots, which they can grow on the cliff sides and become really hard to remove. And also another noticeable one is the blue gum eucalyptus, which will be talked about a lot more later. So we're moved out into the Marin Headlands, which is a little further south of Muir Woods. So again, the Marin Headlands is the ancestral home of the Coast Miwok, just like Muir Woods. In the 18th century, the Spanish and Mexican ranchers, and then with the US acquisition of the land from Mexico in the 19th century, immigrant Portuguese dairy farmers also came onto the land. And the combination of these ranchers and dairy farmers brought on a whole new wave of new grass species, taking away from the native grass species that were found there. And this became a big problem when the military moved in and started building forts and batteries, because at this time, San Francisco became a big booming city. And especially after attack on Pearl Harbor in 1941, they started really ramping up and building a lot of forts and batteries to help protect San Francisco and the port that is established there. So they started cutting in the hills and roads, and forming roads and tunnels and even hitting batteries. But however, they discovered easily very fast that this rock here on the headlands is very easily erodible, as it is made of chert, gray wacky sandstone, serpentine, and shale. And with the farming grasses that were then brought in, they do not hold the soil together like the native plant grasses that were originally there. So with this problem, they were seeing landslides, things falling into the ocean. And to prevent that, they used their heads of, okay, what do we use in the past? And so in the past, they've used ice plant, which they planted along railroad tracks to hold the soil together and keep from the tracks from shifting. And so they started bringing the ice plant and the plant around the batteries and forts to hold the soil together. However, it is an invasive non-native succulent from the coast of South Africa, and it has been able to spread quite widely away from these forts and batteries. And when the military left, they left the ice plant as well. However, Marin Headlands also is a unique, without the military, there is a unique combination of bunch of ecosystems, including coastal prairies, tidal zones, brackish lagoons, riparian ecosystems, and all this is part of this watershed that is created from the topography of the land, which collects all the rain, fog, and moisture that all flow down the hills into the streams and into the ocean. As can be seen through the topography here in the main valley, it is very flat, and all of a sudden when you start going away from the valley, it gains elevation very fast. You can see here, this is Hawk Hill, which Hawk Hill is a very unique place, as it is about 920 feet above sea level. Because of this elevation change, it is consistently in the coastal fog. As I mentioned before, the coastal fog is a great source of moisture and nutrients, and what use these nutrients and moisture is lupins. The lupins are not just random species, but they're very important to the mission blue butterfly. Mission blue butterfly are a federally endangered species only found from about San Bruno to Marin, and they depend on these lupins. They lay their eggs on the lupins, they hatch and eat the leaves of the lupin, and they form their pupae near the base of the soil and around the plant until they hatch. And without these, this plant, the species will not survive, as was seen in 1998 when there was a fungal pathogen that wiped out most of the lupins on Twin Peaks, causing near wipeout of the plant species, leading to a near wipeout of the actual butterfly itself in the area. So Hawk Hill provides this great habitat for the mission blue going forward as climate change continues. If you go below Hawk Hill, we get into the valley where there's, like I said, the watershed where it collects all the fresh water from the rain and fog. And in this freshwater area is the California red-legged frog, which is a federally threatened species. There's an unknown exact number of how many are alive today. However, there are 3 known locations of about greater than 350 adults, and one of them is in the Marin Headlands in the freshwater pond east of the lagoon, as you can see here. But just west of the lagoon, of the freshwater pond, is the lagoon, which is a brackish water made of the fresh water from the streams and the salt water from the Pacific. And in this lagoon, you can find the tidewater goby, which is a federally endangered species. However, also, Marin Headlands is not immune to invasive and non-native species, as I mentioned before, the ice plant. But there is also, again, the Tasmanian blue gum eucalyptus, which was also brought in by the military, primarily as a way to beautify the land, but also as a way for wind blocking, because the wind here in the Headlands is very strong coming off of the ocean. The National Park Service has been working on slow removal and replacing with native species. However, they are unable to remove all of it at once, as the land is now dependent on the ice plant to hold the soil together, and removing all at once would lead to a lot of landslides and erosion, as there's not enough native plants to just replace, and also they have to rebuild their soil networks. And on with the blue gums, they created a new habitat that the National Park Service wants to protect that was not there originally, and also because there's a historical element with these blue gums for the military. And just like Muir Woods, there was a decrease in fog, a decrease in precipitation, an increase in temperature, an increase in drought severity, and also an increase in potential evaporation, all of which have caused less fresh water in these freshwater systems, causing a danger for the red-legged frog, which also leading to rising sea levels, causing the lagoon to become more saline, lowering the water temperature, causing the water turbidity to go up, and creating a loss of the habitat for this tidewater goby. There is a 12-foot barrier between the lagoon and the Pacific. However, 12 feet is the actual projected height of high tide and storm surges in 2100. And the freshwater pond, which is unique because it's fresh and prevents, has no salt and water in it, and it's home to this freshwater goby, the red-legged frog and these other species that depend on this fresh water, is at 10 feet. Meaning once the water gets above that 12-foot barrier, the fresh water will be mixed with salt and cause a loss of habitat for these endangered species. This graphic can be seen in the Headlands. What's notable here is you can see the rise of sea level projections of what it will look like and how the lagoon will no longer become a unique lagoon and the freshwater pond in the back will become mixed with the salt water. And you can see here in this picture, this pole on the left that shows where the different elevations are can be seen here in this picture next to the bridge as you go to the beach. And also this graphic that I said is right here in front of the bridge. So as a way to inform guests about this information and try to raise awareness. So as we move south again, across the bridge, we're going to get into the Presidio of San Francisco. The Presidio is no longer home of the Miwok, it is a home of the Ohlone. The Presidio itself was established in 1776 by the Spanish military until the US reclaimed it from Mexico in 1846 and transferred to the National Park Service and became part of Golden Gate. But here in the land, you can find a bunch of military structures such as buildings, forts, and batteries with Alcatraz right across the water from it. The Presidio itself is about 1,491 acres, 800 of which are open space, 300 are historical planted forests, and 145 are native plant communities. And with, like I said before, the geologic history, for the past glacial action forming these massive sand dunes, these sand dunes have created a large ecosystem habitat that's unique to the area. And because of the planting of other trees from the military, it created a whole wide variety of different ecosystems and habitats that exist here. However, there are 12 plant species that are designated rare, threatened, or endangered, 5 of which are in the dunes, 7 of which are in the serpentine soils. But most noticeable of them are the Presidio clarkia, which is only found in the Presidio and East Bay Hills, the San Francisco spine flower, which is only found in the Presidio in Daly City, which is the south suburb of San Francisco, the Marin dwarf flax, which has less than 20 known locations, and one of which is in the Presidio, and then also the Ravens manzanita, which has only had, in 1987, had only one in existence, in which they made clones and were able to plant this plant around the Presidio. However, like with the lupins and the fungal pathogen, there has been a fungal pathogen in the last 2 years that has created a large die-off of the species. So there it is. However, again, it is not immune to invasive species here. There are a lot of cypress, pine, and the Tasmanian blue gum again that are here. Again, they were all planted by the US military as a way to beautify the land and as a wind block to protect the fort. But they are not the only species that we find here that are invasive, such as the black acacia, the Himalayan blackberry, the Monterey pine, and also the Monterey cypress. And all of these invasive species, not native species, a lot of them are, they threaten habitats of these native species and also take away resources from these native species that need the resources. However, the National Park Service does partner with the Presidio Trust, and they are actively fighting non-native species and actually planting native species in their place. Again, the climate impact is all the same as Muir Woods and Marin Headlands, with a decrease in fog, a decrease in precipitation, an increase in temperature, an increase in drought severity, and along with the increase in potential evaporation, all of which have created bad results for the native species in the park. But what does the Park Service actually can do about this with their funding and management? Well, the land again is about 128.167 square miles, and it sees about 15 million visitors per year. So it's Golden Gate, which is managed by the National Park Service, which is managed by the Department of the Interior, which is again a branch of the United States government. And so it is not it is part of like the budget and funding of bureaucracy, and so it has to deal with all the government spending stuff. However, there is a general management plan and environmental impact statement, which they list preferred alternatives to connect people with the parks. And along with the superintendents, there are also a large number of staff and also a really high volume of volunteers, which allow for great protection of the park and work on removing these invasive species. The budget for the park in 2019 saw $27,234,000. And that budget is to pay the 255 employees in the park, protect and preserve the land, the historical structures, the archaeological sites, the miles of bay and ocean shorelines, the federally endangered species, there's 19 separate ecosystems, the National Historical Landmark Districts, and even the largest museum collection in the National Park System. And again, also the most visited park in the National Park System. And with all these things, the park actually is underfunded. Between the 2010-2019 fiscal years, the nominal appropriations for the National Recreation and Preservation Fund have gone down 2%. However, due to inflation, that number has gone down 20%, which is about $15 million. And that is a lot of money when it comes to trying to manage the park, and especially with climate change happening. So this has led to an inflation on entrance fees. Between 2000 and 2021, average price has gone up about 200% in more than 27 parks. which means about $2 to $15, $4 to $25. And the largest rise being found in Glen Canyon, which is about a 500% increase. And this creates a lot of major inequality problems, as it makes it more difficult and nearly impossible for people with lower incomes and fewer resources to actually visit the parks. And this creates a really big ethical dilemma for the Park Service, as their mission is to protect and preserve the natural and cultural resources while also providing wide access for the enjoyment, education, and inspiration of this and future generations. So if you can't provide wide access for enjoyment and education of this generation, it makes it hard to do that, but also if you need to limit the people coming to the park to protect and preserve the natural and cultural resources for the future generations. So this is a big problem that the National Park Service is trying to figure out. But what the Park Service actually is doing though right now, due to the low funding, they're still working to continue educating the public and protecting the land. And they also recognize that climate change is actually happening now and it's not potential in the future. So they're working to adapt and reduce emissions, and they've partnered with many organizations such as the Bay Area Inventory and Monitoring Network to monitor ecological changes in the park. But they're also conducting inventory on park culture and natural resources and assessing risks of climate change before they even start new construction and maintenance and repairs, and even improving on the buildings that are already there by improving their heating, insulation, and even the lighting efficiency in these buildings. But Golden Gate itself is actually 100% renewable electricity as of 2017, due to a large number of solar panels found on Alcatraz and Fort Mason, and due to and also purchasing renewable power from the community. And also due to get the Alcatraz takes a ferry along with Angel Island, and these ferries are now powered on hybrids. So it's solar, wind, and diesel power. So if you have been to these Alcatraz or Angel Island in the past few years, most likely you have been on these hybrid ferries. But along with that, most of the park vehicles are hybrid or electric, and they're again continuing to remove invasive species, educate the public, but there has been a decline in CO2 emissions. So what they're doing has been working. However, only 4 of the actual emissions in the park, only 6% come from park operations, while 94% actually comes from visitors. So while they're doing a lot to what they can do, but there's only so much they can do due to the number of emissions coming from visitors. So looking forward into the future, we're expecting to see an increase of temperatures and drier habitats, a higher frequency of drought, which all of this will lead to increase of wildfires and more burned areas. And along with that, there are also changes in ocean currents, leading to a drop in oxygen levels, which will disrupt the food webs of the ocean and increase the salinity of the water and the water level of the San Francisco Bay Area. This will lead to a loss of many endangered species that are also keystone species, which with the rise of water temperatures of the ocean, we'll also see potentially a drop of gray whales coming to the coast, as they are also an important part of the coastal ecosystem. And as is seen in San Francisco today with extreme heat days, for the threshold being 97 degrees, the historical average is about 4 days a year. However, as we see, it projects to get higher, and by 2100, getting over 80 extreme heat days per year. And San Francisco Bay Area is not alone, as California itself is seeing a rise for the future, and even today. So California itself is the 3rd largest state, with being the most populated state in the country, and more than 80% of it being covered in forests and rangelands. California is also the top agricultural producer in the US, feeding California, the US, and other countries. So if the rise in these conditions of climate, we're gonna see a drop in production, leading higher food shortages and inflation of prices. And along with the agricultural side, California is also the 4th largest. If California was a country, it'd be the 4th largest wine producing country in the world. And all of these parts of the agricultural wine and the forest all require a large quantity of water, which has already been a drop of. And we're seeing less snowpack as well. So, and with less snowpack, the snowpack is melting found earlier, it's melting faster, and this trend gets worse. And what this means is that there'll be an earlier release of water, which will overwhelm water storage facilities, increasing flood risk and water shortages for the California and West Coast area. However, like I said, water is essential for these areas, and with the loss of water will increase floral death and increase of dry brush, leading to more dangerous and deadly fires, in which the Western fire season has already started earlier. It's already lasting longer and it's been more intense than it has in the past several decades, with projections going up to 10-fold in the future for parts of the state. And what this means is more fire goes up means more smoke and more toxic air, which is not just bad for the human population, but bad for the agricultural business, as plants themselves in the soil will absorb the smoke. And there's already seen a loss of grapes and revenue from the smoke conditions. And even Australia itself, between 2003 and 2015, has seen more than $286 million lost in grape and wine revenues because of smoke. And as you can see, this is the burn area for California, increasing by up to 10-fold in parts of the state, including around Redwoods National Monument. And along with the shrieking snowpack, rising temperatures, a shorter and more intense wet season, and more volatile precipitation and dry years. So looking forward for California, water is not just essential for these agriculture areas, but it's also essential for fighting fires. With 85% of the California population living on the coast, sea level has already risen about 8 inches since 1900, and is projected to go up about 20 to 55 inches by 2100. And this means there's a higher risk of flooding, threatening more than $100 billion of property infrastructure, which includes power plants and hazardous waste sites. And that will also lead to higher coastal erosion, saltwater contamination, and drinking water sources for most of the population in California, but also contamination in the farmland water sources. And along with that, the carbon dioxide parts per million has gone up. And this is also in Golden Gate, just between 2005 and 2016, how much it has risen. And this is a really high number, as it is highest as ever been in historical levels. And that is here on the left, 400,000 years before 1950. And the previous level being around 300, and we are again over 400 as of today. With the NOAA models projecting global average temperature also going up between 1.1 degrees Celsius to 5.4 degrees Celsius by 2100. So what can you do about these things? If you're here watching this right now, you're doing step one, you can educate yourself. And now you can pass on that and continue educating yourself and pass on that knowledge to others and educate them about climate change and the issues facing us. There's a long list of things you can do. A lot of them are pretty simple, such as taking shorter showers or walking places or reusing bottles. But big things you can do is also talk to government representatives and promote climate action right now, and not 5 years from now, not 10 years from now, but actually action right now to start working on this stuff, and investing in renewable energy for your home, community, school, and businesses, and even getting like electrical and hybrid vehicles. So there's a lot that you can do, and a lot of them is very easy. And as the United Nations Secretary General Antonio Guterres said in 2018, climate change is the most important issue that we face. So moving forward, climate change is a big issue that we need to face and start worrying about now, as it is no longer a future issue, but it is something that's affecting us right now. So I'd like to thank all these people who have helped me along the way to complete this project and the research. So I just want to say thank you to anyone who, even other people not on the list, thank you. So is there any questions?